Hi everyone, thank you again for attending another Open Cluster Management Community meeting. We have a lot to cover today, so let's get started. In the second half of the meeting, Li Yang will talk a bit about the placement API, but right now we're going to talk a bit about Ansible integration for application lifecycle. So we're very excited and honored to have Matthew Jones from Ansible team to first talk a bit about the Ansible AWX and the AWX resource operator. So without further delay, please take it away, Matthew.
Thank you. Yes. Yeah. Sorry, I don't have any slides or anything. I'm just going to talk through it a little bit. So, um, I'm going to assume everybody knows what Ansible is. AWX um, is the community version of Ansible Tower as it exists today, and so it's the control and execution plane for running Ansible content. And one of the challenges that we have uh, today and in the past is that in order to deploy AWX, you're running standalone Docker, or you have this install playbook that runs to set it up on Kubernetes for you. And this is fine, except that it goes outside of the sort of bounds of normal, like how you would manage applications running on clusters. And it also sort of represents a disconnect in how you would run automation on VMs and bare metal systems versus in a container cluster, and how you would expect the execution of those jobs and that work to sort of proceed. And so where we've been heading lately with AWX is that instead of trying to run Ansible jobs sort of alongside the control plane on the same systems as the control plane, we're really working to externalize the execution of tasks from the management of who can run those tasks, what those tasks are, how they're scheduled, and what systems they're scheduled on. And so as part of the AWX project over the last year, we added a feature to AWX called container groups. Container groups allow you to use the Kubernetes scheduler instead of AWX's internal scheduler, so that when you kick off a job, AWX itself talks to the Kube API and says, hey, here's the playbook and the image and the launch parameters of those. Go run those, and AWX can check in on this pod and track the status of it. And so this has been great. It means that you can have on-demand capacity scaling for running automation from AWX, but it doesn't help us with sort of the deployment and management of AWX itself on the cluster. Like, realize that AWX doesn't need to be installed on cluster to use the resources of the cluster. So you could have AWX living in a virtual machine and say, here is 5 Kubernetes clusters that I want to use to run jobs. And, this is my North American Kubernetes cluster. Here's my GCP cluster. Here's my Europe, my APAC clusters. And it doesn't matter to AWX. You can just say, here's the credentials to get to my Kubernetes jobs targeted at these systems or managing this particular type of infrastructure. Use this cluster, and these other jobs can use this other cluster. So you can use this whether you're on cluster or off cluster. You just configure AWX to know where your clusters live, and it can fire off jobs to the right one. And so this is great. This allows very flexible scaling of automation, which I know Open Cluster Management is very interested in. We're combining this by rewriting our deployment mechanism for AWX into an AWX operator. This is also great. This means you can use the standard operator semantics for deploying, upgrading, backing up, and restoring AWX on cluster. And it works sort of with your cluster to support secrets and config maps and all the other good things that you would use to deploy and manage an application service on cluster, while still retaining the features of being able to run work from any cluster that you have, or even in the future off cluster. The AWX community maintains container images and execution environments that match different versions of Ansible, different sets of dependencies and requirements, roles and collections that you might want to use. So you're not bound to that conceptually, right? Like AWX is distinct as a control plane, as a management unit from what and what's running and how it's running. So you can have one AWX and a set of containers that are Ansible 2.9, Ansible 2.10, 2.8, 2.11. You can have container images that are specifically for managing Cube. You can have container images for managing network infrastructure, load balancers, and other global infrastructure. It doesn't matter. And so we enable this through the AWX and AWX operator and sort of the combination of those. Also, the life cycle of AWX running on cluster and being able to upgrade and manage and backup restore those things in a way that you expect. And so this brings us to the resource operator. So one of the key components, one of the key architectural ideas of AWX is that it has a full REST API implementation. And when I say full, there's no functionality hidden from AWX as an internal component of AWX that's not also available via the API. The front end for AWX uses this. We know a lot of people just don't even use the front end for AWX and instead use the API as an interface from some other system. This is great, but when you are running in OpenShift and you've built your tooling and your infrastructure around managing applications through the operator semantics of a kube cluster, having to write applications to communicate with the REST interface for AWX is divergent from what you want that to happen. Right? Certainly you can have ingress policies and expose the API, but then you have to go and write interfaces when your other applications may also be running on cluster. And so what we've done with the resource operators is we've looked at the key components of the AWX API that external systems may be interested in interfacing with. Right now it's jobs, job templates. In the future it'll be more than that. But one of the most critical components is, hey, I've defined the jobs that I want to run. I've configured the environments that they're going to execute in. I have all of the details here managed using a software development lifecycle. I just want to give other systems, maybe running on cluster or cluster adjacent, the ability to kick off work, check on the status of that work using the operator interface itself. And that's what the resource operators do. They use the AWX modules from within Ansible and build a one-to-one mapping from those modules into an operator. And so you could start the operator using very simple YAML that expresses what job you want to run, what parameters you want to pass to it, and the environment that you want to execute. Anything that a normal job launch on AWX would take, you can express those through the operator, and you can create this resource and then follow that resource as AWX progresses through its lifecycle. And once it's done, you have an object, a resource, an operator that you can use to track sort of the status of that. And this is where I'm really excited about the collaboration between the AWX team and the Open Cluster Management team, is it enables a very dynamic sort of automation philosophy within a group that may want to use it, right? Like you don't have to sacrifice the work that you've done on automation using Ansible just to use something else, right? Like you can build that sort of separation of concerns. You can put automation in the place where it makes sense, rather than trying to shoehorn cluster lifecycle management into Ansible or network infrastructure management or whatever doesn't make sense for open cluster management, and it brings it together. And this is so exciting to me that we've sort of realized this vision of like how do we automate anything and express policies and constraints and requirements in a simple system that brings anything that we could possibly want to manage anywhere in the world across an entire estate into one single solution. I think that's really powerful. So that's all I had.
Thank you, Matthew. That was great. That was a quick intro to AWX as well as the excitement around integrating with open cluster management. And I just want to bring back to the point that, hey, we got these three pieces that are tied together. We got the Kubernetes, we got the open cluster management, we got the Ansible. So of course, not like what Matthew said, not every IT companies are ready to have cloud native applications. So of course, Kubernetes is good at what it's doing, but Ansible is still way popular and powerful in terms of automating all the existing IT environment. And with open cluster management, we can all tie it together. So for one of the integration, as Matthew explained, for the resource operator, we leverage that to perform pre-hooks and post-hooks of application delivery. So when we have on Open Cluster Management Hub, when we have the application lifecycle add-on installed, you can create a subscription that has pre-hooks Ansible jobs and post-hooks Ansible jobs, so that the pre-hook might be configuring the database, and when that job finishes, then we can do the Kubernetes deployment. And when the Kubernetes is deployed, we can do the post job, which can be maybe open a port on a firewall, some kind of network configuration that Ansible AWX is really excelled at. So this is the overall architecture we've designed for the application lifecycle, and it's all bound and managed by GitOps as well. So just to do a little demo here, we have, if you want to play with the demo, go ahead and fork the multi-cloud operator subscription repo. So I have here, I already forked the repo, and then we can take a look at the Ansible example. So in the application, in the app subfolder, this is where we define all the YAML for the subscription. And of course, you can go ahead and edit the channel properly so that it watches the proper fork repo. And then the secret is the tile access to the AWX environment. We're not going to get into too much detail of that. There's documentation about that. And then once you apply this subscription, then it's going to watch us for the resources here. So I want to talk a little bit about the resource that it's watching. In this example, there's a really simple config map that is deploying, but what's interesting is the pre-hook and the post-hook. So in each of these folders, it'll contain an Ansible job. In this case, we're just running a demo jobs. And what it'll do is it'll first execute the pre-hook, and then when the pre-hook completes, it'll deploy the config map, and then when the config map finishes, it'll do the post-hook. So again, the post-hook is just something simple right now. So I'm going to go ahead and demonstrate that. So on my left terminal, I have the hub cluster, and on my right, I have the managed cluster. And so I already pre-applied the application subscription, and we can see when it finished running, it has the pre-hook jobs and the post-hook jobs that it did. And then on the managed cluster side, we can see the config map being deployed as well. So if we take a look at the Ansible jobs that it creates, so in this case, it created four Ansible jobs because most likely a placement will change, and I'll talk a little bit about that as well. So let's dig into one of the Ansible jobs. So without showing too much details, because of sensitive information, so we can see that, hey, this Ansible jobs um, driven by the AWX resource operator have been reconciled and it has ran successfully. And then we can check some of the job logs. And these are some of the job information that you can see. And what's exciting here is if we go back to the Ansible on the AWX side, you'll actually see the target clusters that are populated in the extra variables field. So you can use that target cluster's name for service tickets, for load balancing, for anything you want on the AWX side, and do your automation that way. So that's all I have for the application delivery Ansible integration. Again, we'll probably have policy integration, cluster lifecycle integration with Ansible coming up in the future. So we're echoing what Matthew said. We're really excited about this field. I think the possibilities endless. Are there any questions regarding the Ansible work integration with application lifecycle? If not, I'm gonna let Li Yang talk about the placement API change, placement API enhancement proposal that he's putting up for. Li Yang, if you're here, please take it away.
Okay, thanks, Meg. Let me share my screen. Can you see my screen now?
Yes, I can.
Today, I'd like to go through the enhancement proposal for placement API. We have already created this PR for this proposal. Anyway, anyone who interested in it can hold your comments on it. In this proposal, we are trying to define a placement API to select a set of managed cluster from multiple managed cluster sets. And placement decisions will be generated according to the spec of the placement API. Other components are able to consume the placement decisions of a placement and then place a workload to the selected clusters. We have already collected some user stories for placement APIs, but not all of them will be covered in this proposal. For example, we may need a separate enhancement proposal for those three user stories. And let's have a quick look at the API spec. Placement is a namespace scoped API resource. It represents a selection of clusters in one or multiple managed cluster sets bound to the placement namespace. A placement could have multiple placement decisions. They all have a specific label which point to the placement resource. Each placement decision contains a subset of selected managed clusters. If a managed cluster is selected and added into a placement decision, some components may place workload on it. Once it is removed from a placement decision, for some reason, like update, workload should be removed from it as well. The spec of placement contains two fields. One is a slice of predicts. The relation between them is OR. Another is affinity. This is optional. If specified, it's applied to all predicts. And cluster predict represents a predict to select clusters. User is able to specify cluster size, cluster name, and number of clusters to select in a cluster predict. Another field in cluster predict is required during scheduling, required during execution. It's a cluster selector. If specified, it means the selected cluster should always meet the match requirements. In a cluster selector, user is able to specify the label selector and claim selector. And affinity. Affinity is a group of scheduling rules. Now we only support cluster anti-affinity. It's very similar to the cluster predict. It also have required during scheduling, required during execution fields, but it's linked to a slice of cluster affinity term. If I specify some cluster affinity term, the selected cluster could not collocated with each other, where collocated is defined as the value of the label or claim with name topology K is the same. Now we have two types of topology Ks. One is label, one is a claim. In the placement status, there are two fields. There are a number of selected clusters and the select of conditions. And we have a separate API for placement decision. The reason we have this design is placement may select a large number of clusters. In that case, we cannot put them all into the status of placement. Instead, we want to split them into multiple placement decision resources and use a label to reference to the placement resource. A placement decision contains a slice of these decisions. For each cluster decision, we have a cluster name, available, and a reason why it represents the reason why this cluster is selected. Here is some examples with this new placement API. The first one, we select 3 clusters from a specific cluster set. And the second one, we select OpenShift cluster with specific versions. This one, we were able to select 2 AWS clusters and 1 GCE cluster. The last one, we leverage the affinity feature. We are able to select clusters across different regions. In the design details, we have a user scenario. Normally, class admin will import some managed clusters, and he adds those clusters into some cluster sets, and then he grants permission to a user to access some of those cluster sets. The user binds some authorized cluster set to his working namespace by creating a managed class set binding. And then a user is able to create a placement in the working namespace. I will have a placement controller. It will consume the placement and generate the placement decisions. Placement controller will only select cluster from the cluster set bound to the working namespace. Once the placement decisions are generated, some other components can consume it and apply workload on the selected clusters. There is a limitation on this scenario or design because we use a managed cluster set binding to bind one managed class set to a namespace. Because a managed class set binding can only bind one managed class set to a namespace. So if we want to bind all managed class sets to a namespace, it's very hard for us to do it. Because the number of managed class sets might be very large, we cannot create the class set bindings for them one by one. Even we can do that, there may be some new managed class set created, and this new added managed class set cannot be bound to the namespace automatically. So this is a limitation. Actually, we have an alternative user scenario. In this scenario, we don't use managed class set binding to bind a managed class set to a placement namespace. Instead, when a normal user creates a placement, he is able to set the managed class set explicitly here. And we also have a validating webhook. This webhook will intercept all the requests, or the create, update, and patch request placement. If the user have no permission on that managed class set, he added into this slice, the request will be rejected. Once the placement is created, the placement controller will generate the placement decision. in the same namespace. With this approach, user don't have to bind a manager class set to the placement namespace. But there is some disadvantage. The first one is the webhook can only handle the create update patch request for the placements. If we want to use the manager class set to limit access of cluster for other resource, so we have to either update the webhook itself or add a new webhook. Another one is it's not easy for us to get a list of a manager class set, which we can use for the working namespace. Okay, let's get back to this one. In this proposal, we also have some we also define some workflows and test plan and graduation criteria. So they may not go through. I will not go through them one by one. There is open questions actually. The API group is about the API group of the new placement API. Now I put them into cluster.openclassmanagement.io. An alternative is we can use scheduling.openclassmanagement.io. Which one is better? Maybe you can put your comments on the PR.
Wow, that was an excellent presentation and a really nice document. And so please, if anyone have any feedback, please go to the documents and refer to the PR and provide your suggestions or comments for the enhancement.
Yeah.
I see Michael Elder have a question in the chat. Is there a reason why we're duplicating the availability in the placement decision instead of referring the status of the managed cluster? Lee, do you want to talk a little bit about that?
Sorry, what's the question?
Oh, it's in the Blue Jeans chat. Michael Elder was asking, it seems like there's a duplicated data in the placement decision about availability of the cluster. And can we instead just refer to the status of the managed cluster? So if we go to placement decision,
Yeah.
I think there's availability. Yep, available. And then
the available is only indicate whether the cluster is available or not. We don't include all the conditions of a managed cluster here, really.
Okay. Michael, did that answer your question or?
It does. I think I'm still curious about availability here because is it really availability of the agent, which is typically what is represented in managed cluster, or is it availability of the API server? We've heard from some of the other folks in the community wanting to know whether the kube API server for the remote cluster was healthy. So when we represent availability, I think I'm looking just for a little more context on what it is that we're indicating at least was available at the time the check was last reported. Because the example sort of represents available true, but all you really know is that it was available at some point in time. So when was it last known to be available? Exactly.
Yes.
So here
Yeah,
I would
so
kind of really expect a little more information to know what that means.
Okay. I put more information on the comments.
Well, I guess not just even in the comments, but as a controller, I have a use case. I want to distribute something to a cluster. I have a placement decision that references a cluster. What I think I want to know is availability the API server availability? Isn't the agent availability? That might be something you could address in the comment. But then also as a piece of data that's in that API, when was that availability last known? When was it last updated? Right? It's really more like a status condition than just a
Oh yeah.
Boolean flag.
Yeah, so I think that might be put in a decision, and we are also thinking like we have something like a tint feature. We could something like update the managed cluster with some tint to let the cluster know, to let the other controller know when the managed cluster is added, for example, an unready tint, and then maybe in another proposal we could have a enhance the placement API with a toleration to tolerate that tint with a certain period of the time. So in that way, in the placement API, we could define like if there is a availability, if there is a cluster that is unready or unreachable. I mean, the two might be different. Unreachable commonly means that the agent is not healthy, but unready means that the API server of the managed cluster is not healthy. It could be the different tint, and we could have tolerations on the placement APIs to tolerate that tint. We can maybe just learn from the Node API on how to do that.
I could see that. Yeah, definitely. And just to be clear, that decision object is embedded in the status, right? Placement rule.
Decision object is another API object. So the relationship between the placement and placement decision is like the relationship between the service and endpoint. Like we create a service, and there will be a list of endpoint slices related to the endpoint. The major reason that we want to put the two API is because if we have like thousands of clusters to be put into one placement, that will be a very big update on the placement API itself. In addition, if we, for example, we could have 10 placement decisions, each one with 100 cluster, and then all this placement decision will link to one single placement. In that way, we can somehow reduce API cost when we update the API, and maybe it could be better for the performance of the API server. Yeah.
Okay, so then as a API consumer, I might have to fetch all placement decisions that are related to a placement rule, and that response might include one placement decision object or more than one, depending on how many clusters are recorded as part of that match. Okay.
And I think when Lee mentioned comments, I don't think he meant adding a field into the placement decision. I think he meant comment on the PR, right, Lee?
Yes. Anyone can leave the comments on the PR, and I also have and I also will add some comments on these fields. I'd
I
like
see.
to suggest it.
Okay, are there any other questions regarding
Is
go ahead.
already in the spec, right? The available for the cluster decision.
Okay, I see. So yeah, I think the main question is still the available might be a not quite clear statement here, right?
I think there's maybe 3 specific bits of feedback that I think we're getting here. Being more crisp in the comment to indicate whether you mean availability of the agent or availability of the API or something else.
Mm-hmm.
Potentially changing the way that we represent availability from a Boolean to something that has a little bit more information, like when it was last recorded, much in the same way that node health is reported, right? There's a condition state and there's a message and a time that it was last updated.
Okay.
And then I think there's Dario, I think if you want to make your comment again, but I think availability
Okay, I had a problem with my. Oh, my point is similar. Can you hear me? Okay, similar to what the relation between service and endpoints in general. Instead of having a true value in available, it should simply the cluster decision should disappear. No, if the cluster is not available, or except if you want to represent something that I don't get it, but okay.
In that case, Dario, is part of the suggestion there to move the decision from the cluster decision array out of the spec and into a status field?
Yeah, that could be a solution. Or otherwise, the controller should just simply remove the decision as soon as the cluster is not available, or similar to the endpoint, right? But anyway, I will have a look to the full spec because I was not aware of, and I will try to give my feedback. I have some experience with.
Okay.
Okay.
Are there any other questions regarding the placement API? If not, that concludes it. Thank you everyone for attending another meeting. See you in 2 weeks. Thanks. Bye.
Thanks all.
Thank you.
Thanks. Bye.